Okay, we're looking at the same circuit that I used with the title Over Unity or What. What I've done is breadboarded everything neatly, or at least a lot neater than I normally do things, so that we can run the test first with using analog meters and make sure that my readings were not erroneous. And we're using all the same parts. There's the rod that got to 216 degrees. You can see the burnt area at the end. This is the cooling fan, which initially I'll not have hooked up. It draws about 9/10 of an amp. Hooked up, it'll add to that draw from the power supply, but will gain about an amp in the circuit itself. This is the standard 3-volt cell that I've used now on all my tests, and this is the MOSFET part of the circuit, okay, that drives the rod, and these leads here run over to the lab box, and the lab box, you're looking at the amplitude is the level control on the schematic, and the DC offset is the bias control. So just refer to that. So it's just a simple, this is a square wave. That's the coarse frequency adjustment there, and you got the amplitude and all those other adjustments. So we're going to, what's going to be neat, you're going to hear I don't have the magnet speaker hooked up on this one. The way I got this rod just mounted with some brads holding it up, it telegraphs the sound just fantastic through the board there. So anyway, PC power supply using the 12-volt lead out to run anything. This amp meter is going to be the current from the power supply, and this is the cell supply. Now I had originally two identical ones of these. Beware when you buy these. They're only $4.95, freight paid from China. And they say they're 20 amp meters. No sir, they are not. They are milliamp meters, and you have to make your own shunt. You can see the shunt coil I put on the back. Well, guess what? I didn't do a good soldering job on the second one. It came loose and burned out the winding, so I had to come up with this here. So in other words, the only thing about 20 amps is what's printed on the front. So you can buy these with a range of 5 amps or 10 amps or 20, but remember, you're going to have to construct the shunt, and you're going to have to calibrate it. Here's a calibration so that these meters were equal. You see just a little piece of wire between the two coils. That was to make the fine adjustment, so there's a perfect calibration between the two meters. They don't look the same, but they read the same. And then after this, we're going to run it with digital, because it's just so much easier to see the digital meters. Okay, we are looking at the two analog meters. The one on the left is going to measure the current being drawn from the power supply. The power supply, we're using the yellow lead, which is the 12-volt lead, and the big meter, which I got masked off so we can just pay attention to that scale, is in series with the MOSFET to the cell. There is a transformer. The rod is a transformer, but it's a 1-to-1, so we cannot contribute the doubling of current, or better than doubling the current, from the transformer, because it's a 1-to-1 ratio. I have made 5 of these transformers rods, and the only difference has been when using lighter gauge wire is you can't draw as much current through there. The only downside to this circuit is that without cooling, the rod gets tremendous amount of heat. However, that can be put to an advantage using this circuit for some other purpose. So, going to turn it on, and basically you're going to see the needles jump up here, 1, 2, 3, and notice that we're pulling over a little bit over 5 amps in the cell, but we're drawing a little bit less than 2.5 amps from the power supply. So we have what looks like an over unity of over 220 some %, just exactly the way it was when I did the digitals. Now I can change the frequency, and you'll see change. But we're looking for this resonant point, and it's always these raspy sounds where you hear. Right there's the best point. Okay. And so the amplitude is also important. As well as the bias on the MOSFET is very important. The idea here, we're going to use 3 of these identical circuits, which should give me at least 15 amps at full resonance, or close to 50 just coming out of resonance. But the heat will be tremendous coming out of the rod, so we need to do some type of cooling. I'm going to the next scene you're going to see, we're just going to go ahead and show the setup using the digital meters. And the digital meters are so much easier to use. Now, if I had my thing to do it over again, I would have made these meter scales work with possibly just a 5 amp on the power supply, because we don't get even close to 5 amp draw, and use a 10 amp on the current cell. But this is what I had to use. I've calibrated them. These meters are equal. In fact, you'll see when I was prepping the one that I accidentally burned up, I had them absolutely matched. So hang on here. Here comes the next section. Okay, we're going to now run the test again. I want you to look at the arrangement of the meters. The first one on the left is the current being drawn from the power supply. The power supply is hooked up to the yellow lead, or the circuit's hooked up to the yellow lead, and it's outputting 12 volts of current, or voltage. And the middle one is going to be the current being drawn by the cell, and the third one is the voltage across the cell. Now you see that's at about 1.41 right now, 40. It's just the residual from when I was just testing it. It's like a battery. It'll bleed off pretty fast. Not a lot of current being stored in there. This is a simple 2-element cell with a screen accelerator as the anode lead. This works extremely well, and you get a maximum amount. So we're going to turn this on, and we're going to try to bring it up through a few resonance points. And you'll notice what you're going to do is want to divide this number by that number to get your over unity. And this will be, depending on what the settings will be somewhere, excuse me, somewhere between 2.45 and maybe as high as 3 volts. Okay? And by the way, the rating of the power supply itself on this computer power supply is 14 amps, but you can really get a lot more out of it when you're not using the rest of the circuits. You're not using the 3.3 volt or the 5 volts. So you can get quite a few. I've run, I think on this, I've run as high as 40 amps on that. But if you want to build one of these power supplies up and duplicate what I'm doing, try to find a power supply that has the 12 volt rating as high as possible. Okay, we're going to turn it on. You're going to hear the oscillator. Okay, and we're going to, first of all, we're going to kind of go and just sweep the frequency. I'm on the scale. I'm on the 10K scale, and I'm down in the lower part of that. So you can measure the audio frequency. So down here, you can see we're doing very little. We are getting something out, but not much. So we're going to bring it up. Okay, I had to touch up the amplitude just a hair to get it started. So we're looking at adjusting this for the lowest possible current draw. Now we're starting to get there.